Hi everyone, today we are going to work on practical 1 of chapter 8 in our SolidWorks CAM 2025 Black Book. So we have already opened the part in SolidWorks. Now we are going to activate the add-in for SolidWorks CAM. We can also select this checkbox, startup checkbox, if you want to start SolidWorks CAM with SolidWorks at the beginning. And we click on the OK button. Wait for a few seconds and SolidWorks CAM will be added in the ribbon as well as in Property Manager. So here we have SolidWorks CAM added in the ribbon. Now we will start with defining the machine. This part is to be machined using a milling machine. So you click on the define machine. Get this machine dialog box. Here we select the default mill metric machine. You can select 4 axis, 5 axis, but that is not required for a part because it can be machined using 3 axis only. And here we get these parameters like maximum feed rate, maximum spindle speed. You can edit these parameters, but we will work with the default one. Now I'll select the tool crib. Here we get the list of tools, cutting tools that we can use when performing the machining. It depends on the tools available with you. Like you have purchased flat end mill of 14, 16 from the market, then you can add them here. Now the size of cutting tool required for machining depends on the gap which is available in our part. For example, we need to get the minimum gap through which our cutting tool has to move while cutting. So how can we get that? Well, we can get that using this evaluate and measure tool. So we will check the gap in the narrowest position available here. Like we select this face and then we'll select this face. So this red line shows the gap between the two faces through which the cutting tool should move. So here we get the minimum distance of 12 mm. So the largest tool we can use is of 12 mm. This 12 mm defines the dia of tool. But what about the depth? So we will get the depth in the same way. We select this one and then we'll select a center point like this one. So here we get the maximum distance of 27. So this is the depth up to which our cutting tool should go, and this defines the cutting tool's length. The 12 mm is the diameter of cutting tool and 27 mm is the length required for the cutting tool. These are the maximum parameters. Now we'll close the measure box and we open this dialog box again, and here we have ball nose of 10, ball nose of 6 dia, flat end mill 10, 12. So we have enough tools through which we can perform our operation. So there is no need to add any tool here. Now we'll go to the post processor. Here we are going to select the Fanuc post processor 16M and click on the select button. Now hit OK and the machine is defined for our operation. Now we need to define the orientations, like which direction is Z, which direction is X. These can be defined using coordinate system tool, this one. Now you can see that Z direction is pointing toward us and XY is pointing, Y is this direction, X is this direction. But we want Z direction to be pointing upward. So we will click on the coordinate system. By default the vertex gets selected, but you can change that. Okay, we can select any of the vertices, like we select this one, and we can select this face to define the Z direction. For example, if you select this one, then Z direction is like this, but if you select this one, Z direction is like this. So these are the points to be selected, and then we will click on the OK button. So we have defined Z direction upward for our operations. Although the modeling Z direction will point this way, it does not matter for our machining. Now I'll create the stock. So we click on the stock manager. Stock defines the piece of metal from which cutting operation will be performed. In this drop down, you can select the materials. We will go with the defaults, and bounding box is correct for us. Coordinate system is also correct. We are going to use this one, not that one. And here we have added a stock of 5 mm above the model. So the piece will be of 5 mm more than our model, and cutting will be performed in this one. Now click on the OK button. Stock is defined in here, machine is defined here, user coordinate is defined here. Now I'll move to the milling setup. So click on the mill setup, and we define the direction, not this one, this one. So this will be the tool direction moving downwards. Now you can select the check boxes here to define various features, like you select face here and click on the OK button. So face feature is already added in our setup. Now we will extract other features as well. So we click on the extract machinable features. So these features are added. Now if you click on this setup, you can see that the direction is not as per our requirement. So by default it has extracted the wrong features. So we need to delete this setup. So right click on it and click on delete button and select yes. Now right click on the recycle button and empty. So these useless features are now cleared. Now right click on this one and select multi-surface feature. Now select all the faces to be machined in this area while holding. Well, we do not need to hold the control key. You can keep on selecting. And we have selected all the faces. Area clearance Z level, that is the option to be selected, and click on the OK button. Now we will create the face milling operation. So you go here, SolidWorks CAM and new 2.5 and face mill. Click on this one. Select the cutting tool to be used for face mill. We will be using this G12 50 face mill, and click on this feature tab and select this face feature earlier created and click on the OK button. So face milling operation is now created, and we get the operation parameters dialog box. Here we will keep the default parameters, no need to change anything, and we simply click on OK button. You can check the preview of path as well if you want. Here you'll get the parameters like total time and simulation. Click on the OK button. The feature is created, operation is created now. In the same way, we will select area clearance tool from 3-axis milling drop down. So you go to the tools, SolidWorks CAM, new, 3-axis and area clearance. Click on the operation tab. Area clearance is selected. Here we can select the cavity option. Click on the tool tab, and we are going to use a ball nose of 6 mm. If you have not added the tool earlier, you can click on the add new button, and here you can select ball nose, and you can filter using the diameter as well. We are planning to use a 6 mm. So here we get 6 mm, effective length 25, 19. Here we are going to select this tool with the ID 43. Click on the OK button. The tool is selected here. And now you click on the features tab and select this multi-surface feature and click on the OK button. Once again, you get the operation parameters dialog box. Now increase the length of tool. So we click on this one here and we increase the length to 70. I will check the pattern of cutting. So here it is pocket out, lace, pocket in core. I think this one is right, lace one. We can reduce the gap between two lines using this parameter, lace step over. So now there will be better finish while cutting. Click on the area clearance. So here we get the distance in various passes, like along the XY plane. This will be the difference between two cutting passes. Along Z, this will be the distance. So these are the parameters specified here for surface finish. Now apart from that, you'll select this adaptive step down. So the first cut is larger than smaller. Depending on the geometry, it will change the depth amount of cutting. Rest of the parameters are okay here. Now click on the links tab and select to depth by region. So this defines how the links are created between various cutting passes at depth. So it can be by level, so that will make it a fixed distance between two links, and you can select this one to make it dynamic. You click on the advanced tab to define the containment. Well, the parameter has changed now, so we'll click on geometry tab and here select all silhouette. In tool condition, we'll select up to. So this way cutting tool will not cross the boundaries. Click on the preview button to check the preview of cutting passes. You can click on the simulate and you can run this one. If you check the simulation, then you can see that there is a collision between this stock and a cutting tool, but this stock will be removed after facing operation. So we need to run the full simulation for understanding whether the cutting tool is interacting with this one or not. So we click on OK button here, we select this one, then we run the simulation. So here's a collision. And if we look closely, this collision can be ignored because a cutting tool should have cleared this area. So everything is fine here. We click on the OK button. Now we will perform the finishing operation. So click on this one, SolidWorks CAM, new, 3-axis feature and Z level. Select this same 6 ball nose. You can select any of these one. Click on the features tab and select multi-surface and click on the OK button. You need to increase the flute length and overall length. So these are fine now. Now click on Z level. Keep the allowances 0, so this will make it a finishing operation. Now we will define linking between various operations. So here we get a straight line. Set the cutting depth to 100. Okay. Click on geometry. All slots. Well, everything is fine now. So you click on the OK button. Operation will be created. Okay, it's done. After selecting this mill setup, we'll generate toolpaths. Then we can perform the simulation as we have discussed earlier. Now we'll go to post processing. So this will generate the G codes. Specify design name and click on save button and click here on play. So NC codes will be generated for all 3 operations. These are all the details. Click on the OK button and the file generated can be directly used on your machine. So this concludes practical 1 of chapter 8.